Hello, Algebra 2 kids. Today we're going to listen to Rockabye Baby, Lullaby renditions of Led Zeppelin songs. So these are the things we owned when our child was very small. I consider it normal, but, whatever. So that's our nice background, very calming. We're going to do questions, I think it's 14 through 25 in this video. So let's jump in and get started immediately with number 14. Okay, throughout which interval is f of x equals 2x cubed minus 3x squared minus 12x increasing? So I need to view a graph of this particular function. I know that it's cubic, so it should have two turning points. 2x to the third power minus 3x squared minus 12x. And when I get a look at the graph, switch tools here. I get a look at the graph, we get something that looks like this. So, and then way down and off the graph, and then coming back up right here. So there's our basic graph. So I'm assuming this at some point is going to turn around. I do not know where that is yet, so that's what I have to look at. We're looking at where is this graph increasing? Well, it's increasing up to here, which on the graph appears to be at -1, and it's increasing from somewhere in this region and up. Appears to be right around 2 or 3, but I definitely don't want to attest to that until I actually get a closer look, either with a table or by zooming or by using trace maybe. And it actually doesn't matter because I can go ahead and tell just from this information I have so far. It's not increasing from -2 to 0, because from -2 to 0 it's increasing a little, then decreasing some. So it's not going to be that one. From -infinity to -1, that's the correct answer. Because from off the graph to the left up until we get to this peak at -1, this is uphill or increasing. So B is going to be my correct answer. C, from -1 to +2. So I'm assuming that this is probably right around +2. And that is definitely decreasing, so it's not that one. And finally, from -20 to +infinity. -20 would be way down here somewhere off the graph, all the way to +infinity, and no, it is not, because it has this portion of decreasing in the middle. So B is our answer. Moving on to the next question. Click on the region you want to select. You may select more than one region. So what happens with these is these highlight. So the inside of this section or whatever would highlight. The graph summarizes test scores of 50,000 students. The data is normally distributed with a mean of 81 and a standard deviation of 2.5. And you can see your mean up by standard deviations here, 1, 2, 3, and then down by 3. Identify the regions under the curve where only the data for approximately 23,750 students are located. That's a challenging question. So that starts with, I've got to figure out what percentage this is of the entire population that we're dealing with. So that's the first step here. Get this percentage. So when you divide that, 23,750 divided by 50,000. Well, it helps if you actually put in the right numbers. There we go. So we get 47.5%. 0.475 or 47.5%. That's a relationship I recognize because, of course, I deal with these numbers all the time. Well, what are the three things I have to remember here? The 68, 95, 99.7 rule. 68, 95, 99.7. So this is 68. So it's 34 and 34. Then we can take our 95 and subtract 68. And so this is what we do. I mean, if you want to memorize all the parts of it, that's definitely okay. But if you don't, that's 13.5. So this is 13.5. This is the strategy. This is how you figure it out if you didn't memorize the parts. And if you look at 47.5, that is a combination of 34 and 13.5. Then you're going to notice that the numbers are going to match because that's the whole concept that they're trying to test. So what you end up doing with this question is you can highlight two sections. You can get this one and this one, or you can highlight these two, or if you feel like being more creative, you can get one of the smaller section here and one of the larger, like that. Or, and again, if you feel like, if you're feeling froggy, feel like being creative, you can get this one and this one. Any of those four combinations will give you the combination of 47.5%. All right, next question. Type your answer in the box. Use a backslash for the fraction bar, a decimal for the decimal point. I don't remember a couple years ago that it even allowed us to put in decimals for most of the questions, so I think that's new. Realizing that a fraction or a decimal are both totally fine. What is a 0 of g of x equals 9 to the x minus 243? Well, meaning what would equal 0? The g of x part would. So I'm going to set this equal to 0, and I'm going to solve it. I'm going to add 243 to both sides. Now, of course, you guys could put this in a calculator and try to find it that way. You can graph it and find a 0, but I want to do this algebraically on the paper, screen, whatever. So now I have an exponential equation, and the only way we learned how to deal with anything with exponential equations was to get the two sides to match bases. 243 is a power of 3. If I divide 243 by 3, I get 81. 81 divided by 3 is 27. 27 divided by 3 is 9, and then 9 is 3 and 3. So 243 is 1, 2, 3, 4, 5, the fifth power of 3, so 3 to the fifth. Once you get to there, you can set the exponents equal to one another. If the bases are the same, the exponents are equal, and x is 2.5, or you could type 5 halves if you prefer. Right, if you graph it, you should be able to get a general gist, but you're going to have to be really careful because since it's a plug-it-in question, you're going to want to make sure that you really know that it's 2.5. So what you probably would end up needing to do is use your table a bit and keep going closer and closer and closer to larger and larger numbers to see if what that approach is. All right, that wasn't too bad. Next question. More functions, more graphing related questions. Click in a box to choose each function you want to select. You must select all correct functions. So here's the parent functions shown. So it looks like it's a rational graph. I can tell that because of the asymptote, which usually only happens if you have limitations on your domain. So I know it's a rational graph, which all of these are rational. Remember, rational meaning it's got an algebraic fraction in a fraction where more than likely you have a denominator that contains a variable. So let's graph the first one, which gives us something like this, which is definitely in the same family. Okay, it's just reflected downward. So this is definitely in the same family. And what I'm noticing is when you look at the second one and you graph that, you get the hyperbole, or hyperbola. I always do that. It's not a hyperbole, that's language arts. Hyperbola graph, like so. And I think what happens is with the squared, they both face the same direction. And that's what you have here. They both face the same direction. This, definitely not the same family. This one would be, when you go ahead through, always switch colors on the highlighting. Let's switch it back. This one definitely is. What this one does is the same thing, except it shifts over. I think it did like that. Okay? And then this last one is similar to this red one over here, where it's going to give you something along these lines, except I think it shifts, so it probably shifts this way. Shifts the whole thing this way, because that's a horizontal change right there. So the two that you would want to select would be this one and this one. Next question. Click on a box to choose each x coordinate. You must select all the correct x coordinates. So this is a system, a line, and a parabola. Again, that's what we seem to get every time, line and a parabola. So remember, a line and a parabola can have two solutions, one solution, or no solutions at all. In this case, we know that it's got at least one. I'm going to assume there's two, but it could be one. I doubt that it would ever be 0. That would that would be really unfair. That would be just patently unfair. I'm going to use substitution. I'm also going to use a different color. Let's go back to blue. Y equals x squared minus x minus 6. That's going to replace the y in the first equation. So 5x minus 4 times the quantity x squared minus x minus 6 minus 11 equals 0. 5x minus 4x squared plus 4x plus 24 minus 11 equals 0. Combine my like terms. Leading coefficient is negative at the moment. I'm going to fix that in just a second. And multiply everything by -1, make it 4x squared minus 9x minus 13. You could at this point graph it and look at the table, or graph it and look at your, use your second calc intersect to find your zeros, or you can factor this, in which case you would be factoring it to, it comes out to x plus 1, 4x minus 13. Now I factored it on a separate sheet of paper, so no, I did not do that in my head. But I'm not going to review factoring at this point in the game. I think that's something you guys have pretty well down. But you are going to want to remember to set this equal to 0 and solve it we get 4x equals 13, and divide by 4, and x equals 13 fourths. And 13 fourths is indeed equivalent to 3.25. Notice though that is definitely positive, so make sure we get the positive. This one gives me a 0 of -1. So those are the two solutions for the x coordinates of the points in this system of functions of, in this case, this linear and nonlinear system. Okay, about halfway done. Factored form, this one's going to be nice and fast. Factored form of 125m cubed minus 343. So we have a difference of cubes. Let's write out the difference of cubes pattern. Binomial a minus b, trinomial a squared plus ab plus b squared. And in this particular example, let's figure out what's cubed. Well, this is 7 cubed. 343 is 7 cubed. It's a number you should probably generally know. 6 cubed is 216. Those are a couple you should know. And if you weren't sure, you can always trial and error it with your calculator. The other one is 5m being cubed. So we got our binomial already, 5m minus 7. And then our trinomial is 5m the quantity squared, which gives me 25m squared. And then it's plus 5m times 7, which is 35m. And then it's plus b squared, the second thing squared, so plus 7 squared, which is plus 49. Completely ran out of space. So it's not the one with the minus 49, so it's not D. It's clearly not A. There it is in B, because this one has the wrong middle term. So B is your correct answer. Next one. Cube root, simplifying a cube root. So 576. So we need to know how we can simplify the numerical part of this. Let's look at how we can simplify the variables first, though. You should never know if that might help us eliminate answers. We got 8 thirds for the exponent on n and 27 thirds for the exponent on p. So this one's easy. That goes to a 9. So we have to have an x to the 9th outside the radical. Excuse me, p to the 9th outside the radical. So it's not b or d. Now I can think about the n. We would have to have an n squared outside and then an n squared still left inside, because this is n to the, let me write it out real quick so you can see where that came from. This is n to the 6 thirds times n to the 2 thirds. 6 thirds is 2, so that's n squared. And this one is the cube root of n squared. So there has to be an n squared left inside, which both of them have. Now we can look at the number. Actually, I don't even really need to do that. Look, 192. What's 192 cubed? Because keep in mind, if it was inside the radical sign here, 192 cubed would be the number inside, is 7,077,888, so it's clearly not D. But let's do the prime factorizing of 576 anyway. 2 and 288, which is 2 and 144, which is 2 and 72, which is 2 and 36, which is 2 and 18, which is 2 and 9, which is 3 and 3. So there's 1, 2, 3 factors of 2. 1, 2, 3 factors of 2. So 2 2's have to come out. 2 times 2 are 4 outside, with 3 times 3 left inside. So that'd be a 9 right there. Excellent. Next question. Regression. 2 ways to do this. 1, graph the scatter plot. Graph and view the scatter plot. So remember to use zoom 9. Okay, turn on the stat plot, of course. Stat plot. And then zoom 9. And then graph A through D, which one fits. Or you get 2 kinds of regression here. You've got quadratic with A and D, and you've got linear with B and D. You can put in the data. Okay, data in the lists. And then you can do a linreg and see if it matches B or D, and then you can do a quadreg. And clearly that first one is not in the right circumstance there. You'd have to multiply that all the way out. If you do graph them, that first one looks really good, but when you get to the second one and you graph it, it's way better. So there's a good visual method, and you know they're both visual methods really, but there's a good method to get the calculator to spit out your equation as well. Moving right along, 4 more. This one's nice and fast. Logarithmic graph. It's the inverse of an exponential graph, so it's instead of going up like this, or like this. It's flipped over and it's going like this. And that's what we're seeing for each of these. Now, what would the plus C on the outside do? It would be a vertical shift. It would be a vertical shift. And in this case, if C is less than 0, we're adding a negative, it would be a vertical shift down, and your answer is D. To get a horizontal shift, you'd have you'd see the added or subtracted number inside the parentheses. That's a horizontal shift. Okay, next question. Inverse of g of x equals x cubed minus 8. It's a nice, easy one to do. We write it down with x and y swapped, and then we solve for y. That's how we find an inverse. Swap x and y, solve for y. So add 8 to each side. X plus 8 equals y cubed. Take the cube root of both sides. Cube root of the quantity x plus 8. C is our answer. That was fast. That was like 30 seconds for that one. Next. Type your answer in the box. Your answer must be in the form of an integer. 200 kindergarten students at T.E. Wright Elementary are normally distributed with a mean of height of 40 inches and a standard deviation of 1.8 inches. Approximately how many students have a height between 37.3 inches and 44.5 inches? So I had to write this one all the way out ahead of time because it can get really iffy when you try to do it by by the seat of your pants on the fly kind of thing. So first we've got to use our z-score formula to find our z-scores. So the lowest height they want minus the mean over the standard deviation. And when you do the math there, you get negative 1.5. So that's a nice, happy, rounded z-score, easy to find on the table. 44.5 minus 40 over 1.8. That came out to a nice, rounded 2.5. Now we're going to look at the probabilities associated with that on the table. This one is 0.0668. Only 6.68% of the kids would have a height of that or below. And this one was 0.9938. So 99.4 of the students, or 99.38% of the students would have a height that or below. Now we're going to subtract them because we want the difference. We want what's between them. What percentage would be included between the two? 668, and it comes out to be 0.927. Then we finally take that and we multiply by the number of kids in the group, in the population. And 0.927, so 92.7%, 0.9, gotta turn the calculator on before you actually try to punch the buttons, Miss Coct. 185.4. And so this made me feel a little better about these type them in answers. The way it said on the practice guide, this one would accept 185 or 186. So that made me feel a little bit better. Because if 185.4, I'm assuming that 0.4, that 4/10 of a child, either gets thrown away or turned into a whole child. Because why would you want 4/10 of a child? Which is getting really morbid, so I'm going to stop talking about that and move on. Last question. Okay. Started the question, and I think I must have hit the pause button, so let's start it again. Type your answer in the box. Type your answer in decimal form, so it must be in decimal form. Let g of x equal 2x squared minus 5. H of x is x over 3 minus 7. What's g of h of 12? G of h of 12. So let's start with h of 12. So 12 over 3 minus 7. If I now want g of that, I can actually make that put that in the place of my parentheses for the function. So let's go through that again. We did h of 12, so 12 over 3 minus 7, and then g of that. So that squared times 2 minus 5. So let's use order of operations. So this is 4 minus 7, so it's negative 3. Squared is positive 9. 9 times 2 minus 5 is 18 minus 5, and we get a 13. And that is our correct answer, and that is all for this video. I hope you enjoyed, and I'm going to go ahead and stop it now before it gets too much longer. Thanks for hanging in there just a couple more days.